We've covered switches and routers. In this video, we're going to round out the hardware picture with a couple of other devices you'll encounter, and then address a question that's actually pretty important to frame correctly. Why is SCADA networked at all? The answer matters because it shapes how we think about risk. Let's start with a few other pieces of hardware that are worth knowing. First, the wireless access point, usually just called a WAP or an AP. This is what extends your network into wireless coverage. Devices connect to the AP over Wi-Fi, and the AP connects back into your wired network. We'll talk about wireless security in more depth later, but the key idea is that a wireless access point is just another entry point into the network, one that doesn't require a physical cable. The modem is the device that connects your local area network to the WAN, wide area network, or the internet. It's the handoff point between infrastructure you own and the infrastructure you don't. Again, a modem and a router might sound kind of similar. A router routes traffic between networks, but a modem makes the connection between your network and the wide area network. So it would operate in tandem with a router, and sometimes they're the same device as well. Finally, there's the NIC, NIC, Network Interface Card. Every device that connects to a network has one, whether it's a laptop, a server, or a PLC with an Ethernet port. The NIC is the adapter that handles the actual physical connection. Each NIC has a unique identifier burned into it at the factory called a MAC address. We'll come back to that in the next module. Here's the answer as to why OT is networked: because it provides real operational value. Remote monitoring means an operator doesn't have to drive 45 minutes to a remote pump station to check something. They can see it on a screen from the control room or from home. Vendor remote access means the equipment manufacturer can troubleshoot a problem without flying someone out. Enterprise integration means production data flows automatically from the PLC to the ERP system upstairs. Cloud historians allow you to store and analyze years of processed data cheaply. These are legitimate business and operational benefits. Nobody networked SCADA systems out of carelessness. They did it because it makes operations more efficient. But the problem that comes with it: each one of these connections that provides value can potentially create a path that an attacker could use. Historically, OT systems were physically isolated. There was an air gap, if you will. If your SCADA system wasn't connected to anything, an attacker couldn't reach it remotely. That isolation is largely gone now. And the important thing to understand is that this isn't a mistake that needs to be reversed. In most cases, the business and operational reasons for connectivity are real and valid. What we need to do is manage the risk that comes with it. And that's what this entire course is about. Next, we're going to look at the physical layer before we go further into the logical side of networking. The next video covers the cables themselves, copper, Ethernet, and fiber, and why the choice of physical media matters in industrial environments. We'll see you then.